Hi everyone, so this is the problem that was asked, homework 10B, problem 1. All right, let's do it. So we got this might be a little bit different. I'm not sure, I haven't checked with the physical textbook, but this is the PDF. It says a 200 kilogram box is lying in an elevator. The elevator moves up through a distance of 5 meters during this process. So it moves 5 meters. How much work does gravity do on the box? And then it asks how much work does the elevator do. All right, so if I have an elevator and I got a box in the elevator like this, let's make the box our object, and I'll draw a free body diagram of the forces acting on the box. So I'm going to assume that it's doing this with constant velocity. All right. And that's just going to make this whole thing a little easier. So there's the force from the elevator. I'm going to call that a normal force, but it's really just the force from the elevator pushing it up. And then there's also the weight pulling it down. So it's the force of gravity. And then lastly, so there's a displacement, and a displacement that we'll say is d going up. So again, work is really just the magnitude of the force times the magnitude of the displacement times cosine of theta, where theta is the angle between the force vector and the displacement vector. So all right, for part A, using that equation for work, it's going to be the work done by gravity. Well, that's going to be the magnitude of the gravitational force times the magnitude of the displacement times cosine of the angle between those two. And so the work done by the gravitational force is the weight, which is 200 times 10 times the displacement, which is 5. And then cosine of the angle between this vector and this vector is 180 degrees because the displacement points up, but the gravitational force points down. And cosine of 180 is -1. All right, so the work done then by the gravitational force is going to be, let's see, 2,000 times 5, that's 10,000, I think. Times -1 though, so it's -10,000 joules. All right, there's that answer. Let's go for the work now done by the elevator. So the work done by the elevator, again, using that same equation, the work done by the elevator is going to be, well, essentially the work done by the normal force. So that's going to be the magnitude of the normal force itself times the magnitude of the displacement times cosine of the angle between those two. So let's see. So the work done by the normal force is going to be the normal force itself. I basically said that if it's moving at a, so if it is moving at a constant velocity, the acceleration is 0, then I can basically use Newton's second law to figure out what the normal force is. So it's going to be the normal force minus the weight, but equals the mass times 0. 0 times anything is just going to be 0. And that essentially tells me that the normal force is equal to the weight. So I'm just going to plug that in there. And that's going to be then the magnitude of mg, which is the magnitude of the normal force, times the displacement magnitude, times cosine of the angle between the normal force and the displacement is they're both pointing in the same direction, so the angle is 0. That means this is going to, oh, not 0, this is going to be 1, cosine of 0 is 1. And then, so we got the work done by the normal force is the weight, 200, magnitude of the weight times 10, which is g, and then 5 is the displacement. So once again, we got 10 times 5 times 200, and I think that goes to 10,000 joules, but that's positive 10,000 joules. All right, hope that helped, and see you later. Bye.